Okay, the first thing we're going to do is actually show the app running. So by default, you get a screen that prompts you for the number of Palantir, the number of beings, and the number of gazing iterations. We'll go ahead and run this app. You can see it's got a little material design look and feel to it. This starts the beings that are running and the Palantir that are being gazed upon. I can click this button here to stop the simulation, which goes ahead and takes it back to the start. You can then go ahead and click this button. It'll restart the computation. If we click these icons, we can rotate the simulation. As you can see here, it rotates, and while it's rotating, it's actually still running. So it never stops running. Even when it rotates, it just pops up a little toast that says continuing simulation, and we can go ahead and shut the simulation down again. And if we were to run it long enough, we would see that it'll eventually stop running, and at that point, it goes back and shows the yellow, which means we're idle, and the gray, which means we're not running at all. All right. Okay, now we're in the source code for the assignment 1A project. These are the skeleton files. If you take a look at the manifest file, you can see that we have an application which defines two activities. One is this thing called the Palantir activity, and the other is called gazing simulation activity. The Palantir activity is the one that just displays the prompt for the number of Palantir and beings and iterations, and then the gazing simulation is what's launched by the Palantir activity, and that's what actually does the real work. There's a number of test programs over here. One is a unit test that runs JUnit, and that tests the behavior of the code. And then we also have more of an integration test, which is running in with the Espresso integration test mechanism, and that actually tests the running of the program, and it rotates the screen and makes sure it works. I recommend everybody get used to running both those tests on their code to make sure it's behaving properly before they submit it. Up here is the actual implementation. As you can see, it's split up into several subdirectories. This is using the model view presenter pattern. There's we'll look at each of these directories briefly. Here's the view layer. The view layer is what is going to be interacting with the user. Here's the Palantir activity. This extends lifecycle logging activity, which is a simple activity that just logs the various lifecycle events so you can see what's going on when you debug it. As you can see here, there's several edit texts for entering in the counts for the Palantir and the beings and so on. And we also have a floating action button which pops up, and you can use that to start and stop the simulation. Down here is the onCreate method that just goes ahead and calls up to the superclass, sets the content view, and initializes the views. All the code here is given to you. I'm just walking through it quickly so you have a basic idea of what it's doing. We come into initialize views. We get the various views that are going to be shown in the content, view layout for the number of Palantir, number of beings, and number of iterations, and also the floating action button that'll be displayed. When you click the floating action button, start simulation is called back automatically. That goes ahead and makes an intent via a factory method in gazing simulation activity, passing in the various fields that were set in this activity. And then assuming that we actually have the gazing simulation activity registered, which it should be, of course, because it's described in the manifest file, we go ahead and start the activity and launch it. So let's take a quick look at gazing simulation activity. This also extends lifecycle logging activity. It has an intent that's used to be able to start it using an implicit intent. It has some list views that are going to be used to display the Palantir and the beings. It's got this thing called an array adapter that's used to change colors as the simulation is running. It has a start and stop floating action button that can be used to start and stop the simulation when you click it. It has something called the Palantir presenter. That's part of the presenter layer. That's really the entry point into the presenter layer, and that's where all the real computation takes place. We have a number of defaults here for the number of beings, Palantir, and iterations. We also have some symbolic constant names that we use when we put these things as extras into the intent. Here's the make intent factory method, which just goes ahead and sets the various fields properly and then returns an intent. That's the action gazing simulation action with those various extras being added to the intent. When this activity is started by the Palantir activity, its onCreate hook method gets called back. It calls up to the superclass. It sets the content view, which is more interesting than the Palantir activity one. It then goes ahead and sets the presenter using a very interesting mechanism for handling runtime configuration changes called getLastNonConfigurationInstance. We'll be talking about this later in the course. Don't worry about it right now. It's just a way of being able to handle screen rotations in a very clean and simple way. If this is the first time in, we go ahead and make ourselves a Palantir presenter object and make that the presenter. If it's not the first time in other words, if the rotation has occurred earlier, then we go ahead and call to the presenter's onConfigurationChange method, passing in the new activity, and that informs it that it's been modified and should update itself so it'll point to the right view. We initialize the views, and then we check to see if the presenter layer is still running the simulation. If it is still running the simulation, because it's not affected by the rotation since it's the presenter layer, we just pop up a toast saying continuing simulation. And otherwise, we go ahead and start the simulation. Here's the onRetainNonConfiguration instance method. This will be talked about later in the course. This is a hook method that's called automatically by Android when an activity is being destroyed during a configuration change. And what it does here is it just returns the presenter, and that way that presenter will be available up here when we restart this activity. So it's a really clean and simple way to pass state between runtime configuration changes. Here's initialize views. It sets up all the various views, sets up the adapters, and then updates the simulation button text. That just changes it to say stop simulation versus start simulation, or more specifically, it changes the floating action button icon. When run simulation is called, we tell the presenter layer that it should be running. We start the presenter layer, and then we update the simulation button text to basically use the icon for stopping the simulation. Here's how we toggle these things. This basically goes ahead and sets the start or stop floating action button to either be the stop or the play icon, depending on whether the presenter is running. So if the presenter is running, we'll set it to stop. If the presenter is not running, we'll set it to start. And that way you can toggle back and forth. Here's the start or stop simulation method. This is called back when the user clicks start or stop. If we're running, then we go ahead and disable the simulation button until all the threads have been terminated gracefully, and then we shut things down. Otherwise, we go ahead and we run a new simulation. Here's the show beings method. These are methods now that are helper methods that either initialize various parts of the display or are used to update the display by callbacks from the presenter layer. So as you can see here, this uses a lambda expression to make a runnable command, which when called will clear the adapter, and then it'll go ahead and add the number of beings, all of which start out to be yellow by default. And then it goes ahead and updates the display. And then it takes this runnable and it says run this runnable on the UI thread. So that'll be used to start the restart the simulation on the UI thread. This show beings method will be called back by the presenter layer. Here's the show Palantir. It does the same thing, makes a runnable command, which is a lambda expression, goes ahead and clears out the previous list, adds a new Palantir starting out with a default color of gray, updates the adapter, and then it goes ahead and makes that run on the UI thread, so it'll actually do the work. Down here we have the marked Palantir method. This is used to change the color to the designated color of a particular Palantir. So that's the index that's passed in. You can just see it goes ahead and sets the appropriate value and then updates the display, and that runs on the UI thread. So all these things here mark the Palantir, mark the being. These are basically just changing the colors of either the Palantir or the beings to be the right color depending on what state the simulation is in. Down here then are little helper methods that wrap the marked Palantir and marked being methods. This will mark something as being free. This will mark it as being in use. This will mark it as being idle. Mark it as gazing, mark it as waiting, and so on and so forth. And these are all called back from the presenter layer to change the way the display is looking. When the presenter layer is done, it calls the done method, which goes ahead and starts everything back from their initial default behavior, sets the presenter to false, updates the simulation button, and then says we're going to be enabled, shows up a toast, pops up a toast saying the simulation is complete, and then takes that runnable and runs it on the UI thread to actually do the work. When the shutdown occurs, we go ahead and throw up a toast saying shutdown has occurred, and then we send that to the UI thread. And here's what we actually do when a thread is shut down. We mark the colors as yellow and say that the simulation is no longer running and run that on the UI thread. The last couple of methods here are just accessor methods that return the presenter, and then there's a mutator method that sets the presenter. Okay, so that's basically the view layer. All that code is provided. Here's where you actually have to do something useful. Here's the presenter layer. And there's two pieces of code here. There's the Palantir presenter and the being runnable. So the Palantir presenter, that's the guy that's doing all the heavy lifting. This is called by the view layer to start the simulation, and it also keeps a reference back to the view layer so it can interact with it to do the updates to the user interface. The presenter layer doesn't access the UI directly. It uses the view layer and the activity in the view layer to do that. Down here, we have a field that keeps track of the configuration change. We have a list of being threads. You'll have to implement this. We'll see the comments a little bit further down. You can see if you look at the blue down here, these are the places you have to fill in the to-do statements. Keep track if the simulation is running. We keep track of how many Palantiri we have and whether they're in use or not. Same thing for beings. Here's a weak reference back to the gazing simulation activity. We need this to be a weak reference because this can come and go, and we don't want to have a hard reference to it, otherwise the activity can't be garbage collected. We keep track of something called a Palantiri model. That's what actually does keeps track of the state of the Palantiri. Here's the constructor for the Palantir presenter. This is called the first time it's created. We set the gazing simulation activity, make a new weak reference to it, initialize the Palantiri model layer, which we'll look at in a second. We grab the intent used to start the activity, which comes in from the view, and then we go ahead and use this in order to be able to keep track of various things. In particular, we use this to initialize our options and pop-up toasts and so on. And of course, we haven't had a run reconfiguration change because we just began. When the activity rotates, when the gazing simulation activity rotates, on configuration change is called back, and this updates the view. So we have to keep track of a different view because that will have been destroyed during a reconfiguration change, and now we get the new view and we plop that into our weak reference so that all the calls here will go to the right view component in the view layer. And at this point, of course, a configuration change has occurred, so we mark that as true. This method just returns that field to indicate whether something's changed or not. Here's the make argv method. This goes ahead and returns a string, an array of strings that will add the various flags that are passed in to set what we want to have shown in terms of the number of beings, the number of Palantiri, and the number of iterations. Is running just says whether we're running or not. Set running sets that field. These are accessor methods that get access to these colors for the beings and the Palantiri. Finally, we get to the interesting part. So this is where we have the start method. This is called automatically by the view layer, by the activity there. That goes ahead and makes the Palantiri in the model layer. It goes ahead then and shows the beings on the UI, shows the Palantiri on the UI. Note how it's calling back to the view layer to do the view operations. And then it calls into the methods that you have to implement. Begin being threads with a number of beings and wait for being threads. So this is the code you have to fill in. You have to follow the comments here. You have to figure out how to create the right number of threads and start them up to run the various being runnables. And then you also have to figure out how to wait for these things to complete. And note that waiting for these things has to be done carefully. It has to be done in a separate thread because otherwise you'll block the UI thread, and that would be a bad thing because your code would hang. Here's a shutdown method that gets called back when things shut down, and here you have to interrupt all the threads to get them to shut down, and that'll require knowing how to interrupt threads, which we'll be talking about. And then we go ahead and tell the view layer that shutdowns have occurred. Here's the get model method that just returns the model. Let's take a look at being runnable. This is also some code you have to implement. Being runnable is a runnable, and so it implements the runnable method. That means you have to create a thread and give it this runnable to do its work. This keeps track of the Palantiri presenter. That's the enclosing presenter, so we can call back to it. We keep track of the number of threads that are currently gazing. These are the number of beings that have a Palantiri, initially set to 0. This is what's called an atomic integer. We'll cover that later in the course. Each being has an ID. We'll see that we do some clever things with the ID here to make it simple to work with. We keep track of the total number of beings that we have from 1 to n-1. Here's the constructor. It sets the Palantiri presenter, and then it goes ahead and increments the being count by 1. And then down here, we have a method that gets the being ID. And notice what we do here is, since this thing is monotonically increasing, we simply take that count and then we mod it by the total number of beings. And that makes sure that we're always within 0 to number of beings minus 1, which is what we need to do to have the view layer present it properly. Here's the run hook method. This is what gets called back when the thread that this runnable is associated with is started. It's going to go through the number of gazing iterations and call gaze into Palantir with the being ID, and this will run in each thread. Notice we do a little pause here so it doesn't start up immediately. That gives it a chance to show the colors properly. And we do a little logging operation so you can debug this easier. Here's gaze into Palantir. As you can see here, this will go ahead and check to see if the Palantir has been interrupted. So I put a false there. You have to change that to the right call. And it's not too hard to figure it out, but you have to do that. And once we've been interrupted, we tell the view layer via the presenter layer that we've been shut down. This is the code that gets run if we haven't been interrupted. We go ahead and indicate that we are waiting. The view layer says we're waiting, and that changes the color to the waiting color. And then we go ahead and increment gaze count and check, which we'll look at in a second. We then mark the Palantir as being in use, and the Palantir will be marked as being in use, and we're going to go ahead and show that the being is gazing. Now, the part that you have to implement is right here, and that's where you have to call into the model layer in order to get a Palantir. And the thing that you're going to do in this implementation, since there is, in fact, no synchronization in the model layer, you're going to have to write a loop that does essentially a busy wait to wait until you actually get a Palantir. That's not an efficient way to do things, but that's the way to do it if you haven't learned how to do synchronization. And to keep from doing excessive busy waiting, you should make a call to pause thread with a value of, say, 500, which is basically, I think it's 500 microseconds. You have to, or 500 milliseconds, a short pause, half a second pause, so it won't change the color too quickly, and that you'll be able to not just busy wait excessively. Once you've got a Palantir, you come down here and do these markings I talked about. You then gaze into the Palantir for a certain amount of time. If you take a look at the code, you'll see it gazes for a random time between a certain number. And once it's done gazing, then we mark the being is no longer gazing, and we mark the Palantir as being free. And then down here, we decrement the gazing count. And then down here, as you see in the finally portion, you have to return the Palantir back to the Palantir manager in the model layer. And we'll take a look at that code in a second. You have to implement that code later in another assignment. Here is the increment gazing count and check method. This basically has to increment the gazing count and check to see if you're actually doing things correctly. If, as it says in the comments, this is a sanity check to make sure that your model layer is working properly. And decrement gazing count is also used as a sanity check. Okay, so that's basically the presenter layer. The last layer here is the model layer. This is where the actual state is managed for this application. We have this thing called a Palantir, which is a class that essentially is going to have an ID and a random number generator. And what this thing does is when you call gaze on it, it'll gaze for a random time between 1 to 5 seconds. And after it gazes, it'll be interrupted. And we have to propagate this interrupt for reasons we'll learn about in the lectures. And then down here are some things that check the ID, return the ID, and check to see if things are equal, and so on and so forth. So that code is provided for you. Here is the Palantir model method. This is class. This is the entry point into the model layer. All this does is it defines an instance of the Palantir manager, and then it has a factory method that makes the number of requested Palantir and makes a random number generator, gives them their random numbers for gazing, and then sets that as a field. And then we have a couple of methods to acquire a Palantir and release a Palantir. And these are really just facade methods that simply forward into the Palantir manager. So acquire Palantir just forwards to the Palantir manager for acquire. And the same thing is true for release. Note in this implementation, acquire does not block if there are no Palantir available. We'll change that in the next assignment, which will actually do the blocking. Here is the Palantir manager. This is some code you have to fill in. I take it back. You don't have to fill this code in. This code is provided for you because it's very simple here. What this does is it uses a concurrent hash map, and we'll see how it's used. It uses some really cool Java 8 features, which you're not expected to know, but I'll explain them because they're really fun. Here's the Palantir manager. This takes the list of Palantir that were created by the factory method, makes a new concurrent hash map, and then for every element in that hash map, we're going to go ahead and, for every element in the list of Palantir, we're going to go ahead and put that Palantir into the hash map with its field set to true, which indicates it's available for use. So at that point, the Palantir manager has been initialized, all the Palantir are in it, and they're all available. When acquire is called, note what we do. This is a super cool mechanism available in concurrent hash map called search. And what search does is it will atomically go and look up in that concurrent hash map, and it will check to see if anything in here has the value of available. And it'll basically return one of those items. In fact, it looks it up in parallel. It'll concurrently look up in the map in the list of values, and it'll find some value that's available. It doesn't matter whether it's the first one, the last one, as long as there's one in there. And if it finds one that's available, it'll go ahead and update the map to indicate this one is now in use. False means that it's not available. It means it's in use. And then we return the Palantir that was found. So it'll atomically look up, find one if there is one, and return it, and then mark it to false. Otherwise, it returns null. So what'll happen here is, and this is all atomic. You don't have to worry about locking. So within one simple operation, and by the way, I should delete this because you don't have to fill anything in here. What we're doing here is we're looking up atomically to find out whether there is anything in there that's available, and we return it if so. Down here, release is called back, and this basically goes ahead and will, oops, we don't actually have to hold this lock because this is a concurrent hash map, so let me delete that. So all this does is this goes ahead and just atomically updates the Palantir map to indicate that this thing is now available. And again, that's a safe operation and very efficient because of the fact that this thing has been set with a concurrent hash map. Later assignments will have you come along and implement this in a different way once you learn how to use synchronization mechanisms. The final operation here is another totally wacky Java 8 call. This is called available permits, and what this is doing is this is going to look into the map, and it's going to find how many values in the map are currently true. In other words, they're available. So that's the available permits, right? The number of available things. And you can see here we use this interesting method called reduce values to int. And what this does is it's going to go in parallel. That's what the one means. It says run this thing in parallel for however many threads we have in our fork join thread pool, which we'll talk about later. Go and see which of the values are actually true, and we're going to return 1 if a value is true and 0 if it's false. And then we set this thing to 0, and then we go ahead and we reduce them by adding all these numbers together. So if, let's say we have 6 Palantir total and 2 of them are available, this will return 2. And this does it in a very cool way using a reduction operation, which is a very interesting part of Java 8 and Java 8 streams. Okay, so that's basically the skeleton. As you can see here, the only thing you have to actually implement is the part that's over here in the Palantir presenter, and those are the blue lines, as well as the being runnables. And those are also the blue lines. That tells you what you have to implement. Okay, and that's it.